Hello and welcome. I'm Steve, and today I'm excited to introduce the new dynamic compaction feature in Settle3. Dynamic compaction simulates the real-world process of dropping heavy weights onto the ground to densify the loose soil, making it tighter and stronger. For engineers, this means you can quickly calculate two critical components: how much surface sediment will be reduced, and how deep into the ground the improvement actually reaches. So why is this important? Because excess or uneven sediments can create cracks in slabs, tilting of the columns, or shorten the lifespan of the pavements. The problems that cost far more to fix later than to prevent. With Settle3, you can see these outcomes right away before a single drop test is done on site. In the past, the engineers had to juggle through a spreadsheet, sift through research papers, and find the right empirical parameters and equations. Now, Settle3 brings all these inputs and calculations together in one place so you get fast, reliable results. Let's see how it works and what it means for your projects using Settle3. We'll take a look at tutorial 25, ground improvement with dynamic compaction. Let's first go to the project settings. You will see that time-dependent consolidation analysis is turned off. This option is only for immediate sediment, not consolidation. When we go to the stages, you'll notice that we have multiple stages. And this model has staged layered embankments where the dynamic compaction is applied in the first stage, and then consecutive layers of the embankments are built on top of the ground improved region. For soil profile, horizontal soil layers are used. The other methods, such as non-horizontal layers and extruded section layers, are not applicable for ground improvements with dynamic compaction. So you have to stick with horizontal soil layers. There's no groundwater analysis on this example. So let's press OK. When you go to soil, you'll be able to define the ground improvements and assign dynamic compaction for the region that you specify. For this example, as you can see from the 3D model, that there is a region of dynamic compaction that's already been applied. So we'll take a look at this by selecting edits in the ground improvements. And you will see, once we select this, the three main inputs that is required from dynamic compaction. So we'll step through each one. Drop point layout has a pattern of square or triangular, and you can find its spacing and the drop height. And you can also define temper properties as well with the shape of the base, whether it's circular or square with its diameter and the weights. For dynamic compaction settings, you can choose the calculation method either by using CPT or SPT, and you'll be able to calculate the energy over either N or E over QC. You can also define the NC, the empirical parameter, by selecting on assign NC from reference, and you can choose different types, a different range of values of NC from the empirical parameters from Jiehan paper in 2015. And you can find number of passes and number of drops per pass. And this is where you'll define the stages at which the dynamic compaction is applied. For hourly pass, there's also the drop pattern of square and triangular. And can also do the drop spacing, number of drops, drop heights, and temper weight for hourly pass as well. And when you assign these properties, you will see its applications on the 2D plan view after you exit this dialog. For calculating the peak particle velocity, you can enable this option as well. Well, you'll be asked to put a distance to the nearest affected structure, and Settle3 will calculate the impact of your drop height and its surrounding structural impact with the PPV parameters. So once you select OK, as you can see, the plan view shows the hourly pass and the temporary pass, and you get the empirical results on top of your loads, such as the depth of improvement, applied energy of the hourly pass, applied energy of the high pass, total applied energy, SPTN after improvement, E after improvements, depth of crater, estimated induced sediment, and peak particle velocity. You'll also notice that the sediment has been calculated in reflection of all the properties that we assigned with dynamic compaction. So if you want to see the settlement before the ground improvement, so we'll show you this by deleting the ground improvement. And you'll see that we have 144 millimeters of sediment before the ground improvement with dynamic compaction, as opposed to with dynamic compaction that you get 89.7. So this shows how you can apply the dynamic compaction with the right properties to simulate the improved ground region with layered staged embankments. Dynamic compaction in Settle3 brings a robust, streamlined way to model immediate sediment reduction and ground improvement accurately. By making these complex inputs easy and results transparent, you save time, reduce risk, and create designs your team and clients can trust. Thanks for watching, and visit our website to explore more features and unlock full power of rock science software with its comprehensive ecosystem.